or the guidelines to doing this. We are talking about how to do partial fraction decomposition. Okay, if you have linear factors, so, well, you can't see that. There we go. This is for partial fraction decomposition. Better put that on there since this is a new video. Someone random might watch it and then post a comment that says Z, falling asleep. Okay, so if you have linear factors, then you just use like A over your first linear factor. So that just represents your linear factors. Plus B over your next linear factor. Plus C over your next linear factor if there is one. If there's not, then you're done. So you just keep doing that till you've included all of the factors. Okay? If you have repeated factors, that would be, okay, so repeated factors would be linear factors with a power. So for example, if I had something like x minus 1 squared and x plus 2 cubed, then you actually have to write out separate ones for the individual factors. It's kind of confusing to explain. I just have to like go from here, okay? So you'd have a over x minus 1 plus b over x minus 1 squared. Now that's as high as that one goes, but I have to list it once with no power. Oh, so, or rather the power equals 1, and the power would equal 2 on that one, right? Because it has a power of 2. So whatever that power is, you do it that many times. Kind of weird. So then there's another repeated factor, so we'd have c over x plus 2 plus d over x plus 2 squared plus e over x plus 2 cubed, and then we stop. Do you get the idea of how to handle repeated factors? They're kind of a pain. So this was more of an example than a rule because writing out the rule gets confusing. Basically, if you have repeated factors like this, you have to repeat them as many times as the power is. So since this has a power of 2, you're going to do it twice with that. Once with a power of 1, once with a power of 2. And then since this factor has a power of 3, we have to use it 3 times. First power, second power, third power. Just pausing till I make sure everyone's with me, because that's kind of a weird thing. Are we good? Okay, last one is quadratic factors. And in order for them to be quadratic, they have to be prime. Quadratic factors that are prime. Because if you can factor them, you can turn them into linear factors, and that's what you want to do. But if they don't factor, because they're called prime, then you have to leave them as a quadratic factor, and then you do something different. Okay? If you have quadratic factors, then you have to do a linear in the numerator. Sorry, I just wanted to write that down and then I'll explain. So if the denominator is quadratic, then the numerator has to be linear instead of just constant. And then if you had another one, like let's say this is one set of numbers, you had like another quadratic, then you would have a different linear over the top of that one. Does that sort of make sense? Now, could you have a combination of these rules put together? Like linear factors that you just list once, or linear factors with a power that you have to list more than once with their powers, and maybe throw a quadratic factor in the same problem that has a linear numerator? Would that be possible to have them all mixed together? Yeah. So it can get kind of ugly. Okay,